So today we want to talk about spanning tree protocol. Had some questions about it. So a quick overview of how it works and what it does and what it is and why we use it. So spanning tree protocol is a switching protocol that's used to defeat loops in a network. So there are some rules to how it is set up, and those rules are that the root ports all need to be in forwarding mode. The root ports, or the root switch ports, all root bridge switch ports. So whatever switches the root, all of its switch ports need to be in forwarding mode. All the root ports on a non-root switch, there are root ports, designated ports, and alternative blocking ports, and different types of ports, but all of the root ports need to be in forwarding mode, and all of the designated ports need to be in forwarding mode, and all other VLAN specific ports must be blocking. So by default, every switch that's laid out here is VLAN 1. We can log in here and see. So show VLAN, and you can see I've not built any other VLANs on these switches. They're all just VLAN 1. As far as timers, there are default timers to spanning tree. There's a max aging timer of 20 seconds, a hello timer of 2 seconds, and a forward delay timer of 15 seconds. So as BPDUs, or bridge protocol data units, are sent between the switches, they are exchanging this information, and each switch is going to see a hello timer every 2 seconds. So they'll send these every 2 seconds. Hey, I'm here. Hey, I'm still plugged in. Hey, I still exist. Once a access port is plugged into these switches, they get a forward delay timer. So it has to block, then it learns, right? Then it becomes active and forwarding, that kind of thing. So there's 15 seconds until you actually get forwarding out of that switch port once it's plugged in. Default priorities. So how does a switch know, in a group of switches, how does it know which one's going to be the root, which one's going to be blocking, etc.? There are priorities. So by default, every switch, Cisco switch anyway, that comes out of the box has a priority of 32,768, and each port has a priority of 128. So again, all this stuff is default. It hasn't been changed. If we do a show running config here, you can see I haven't set any specific port priorities or any type of priorities on these switches. So the election process is all switches are going to claim to be the root once they're inserted in the network, because they all share the same priority. So after they're all plugged in together, BPDUs are sent, which contain the priority and the bridge ID. BPDUs are 8 bits long, 8 bytes long, 6 bytes for the MAC address of the switch, which you can get by issuing a show version command. So you'll see here there's the base Ethernet MAC address of this switch is listed up front. And these are 2960 Cisco switches. I'm not sure what type of switches your lab runs on, but in the software I just pulled a couple switches out. So they're running on 12.2, and they're 2960 software. But here is where you will find that base MAC address, because each port will have its own MAC address. For example, if you do show interface, switch port 0/1, it doesn't like that. Oh, that's right, they're just interfaces right now. Hang on one second, let me say show interface FA00. 0/1. Okay, there we go. Sorry about that. So you can see every port has its own MAC address. So what you want, and what's going to be used in the election process, is the actual base MAC address, which is found here. So, after they all get plugged in together, right? So they send these BPDUs around that say, here's my priority, here's my bridge ID, and they're all going to match by default because the priorities are the same. So when that tie occurs, the lowest MAC address of the switch becomes the root. So if you go and pull each MAC address, if you, for example, if you have a bunch of brand new switches and then you throw a legacy, 10-year-old switch in there, it's probably going to have a lower MAC address than the new ones. So you just want to verify that before you go and create issues in the network. You can statically set priorities to make sure that certain switches do become the root every time something is plugged in. Knowing the default, right? If I change a switch to be the priority of 4096, right? It's always going to be the root. So just keeping those things in mind. If a tie occurs, lowest MAC becomes the root, right? So in this topology, you see 0001. These are red left to right, by the way. So you have 0001, 000C, which in hex I believe is 12. So this is going to probably be the lowest, because here, as you move forward, you have 01, 0C, and then 0 or E0. So this is going to be the lowest. So I actually put it at the top there because it is going to be the root of the topology. So, but in the event that say you only had 2 switches and they had very similar MACs, or you wanted one or the other to be the root, and a tie occurs, right? It'll start using the path. So if it's a gigabit port, I believe it's the cost of 4. If it's a fast Ethernet port, it's a cost of 19, etc. So if there's the same path to a switch, it'll use the lowest path and say that switch is the root. And then if that is also the same and there's a tie, and say there's 2 uplinks to the same switch, it's going to use the lowest port ID. So if you have port 24 and port 23 plugged in, it's going to use port 23 to be the designated port, or the root port, right? It's forwarding to the switch. So let's put some connections to these. We'll just start 24 to 24, 23 to 23. Just try to keep it simple and easy to keep track of. And then from here we can do 22 to 22, and use 21 to 21. Remember, like devices, you're going to use crossover cables. Most newer switches nowadays can do auto MDIX, so you can use straight through cables. Usually it's better to do the crossovers just to make sure your pinouts are correct. But in a LAN environment, packet tracer, you can use a crossover cable, you can use straight through. This will auto choose, so if you just click this and go, you're fine. So you look here, they start to converge. You get the blocking and the forwarding going on, and they're starting to learn about each other. You do simulation mode. You can actually send those BPDU packets if you wanted to. But let me just clear filters here. I'll just show none. Edit filters. If we find BPDUs, I believe are in here somewhere. Maybe not. I want to say there'll be UDP. So if we just click, complex PDU from here, I don't know that you can do BPDU. Outgoing port, 1 shot, 5 seconds. Once a destination address. I don't put IP addressing on the switches when I just do spanning tree, just to show how it works. So we won't worry about it. But normally you can see there'll be a broadcast storm here for a little bit. It'll just keep going around and around and around until it figures out which one is blocking. If I turn the ports off themselves, the labels, you'll notice the color changes. So right now you have all 4 green here, so they're all forwarding. You've got 1 green, and so you have 1 designated, one blocking. So this hasn't really learned a lot yet. This should turn, that should actually turn red eventually here. It just takes time to converge. So let's get into some commands, I guess. So like, for example, if we go here and we do a show spanning tree, you'll see that this bridge is the root. Again, it has the lowest MAC address, right? And you see your hello timer, your max age, and your forward delays listed over here. And you can see your priority. It's in 68, 69, I guess. Pretty close. And your system ID extension is 1, because we're all